Good morning, children. I hope you understood the concept of anomalous expansion of water, which I taught on last Friday. Today we'll go ahead with this concept. In page 128, there is something called Hope's experiment. We'll be doing it later, so I'm not doing that now. We'll straight away go to the next topic, that is consequences of anomalous expansion of water. This means, how does anomalous expansion of water affect us in our daily life? So practically, some effects due to anomalous expansion of water we are going to see. Okay. Have you ever wondered, in very cold countries, how, there are places where temperature goes below zero, like minus 30, minus 20 degrees Celsius and all. Now, that means the entire water body, suppose you take this as a lake, okay, lake, the entire water body should freeze because the outside temperature is so low. So that means the temperature inside also should be some minus 20 or minus 30. So what will happen to all the fishes and all the other aquatic animals there? They should be dead. But that doesn't happen, okay. So there is something amazing about this, and this is due to anomalous expansion of water. Okay. So the explanation goes like this. So there is a lake which has fish and other aquatic animals. Now the temperature outside was say 6 degrees Celsius one evening, but that night it became very cold, and so the temperature was going down. In the temperatures go very low in the middle of the night, or they say early mornings, like 2 o'clock, 3 o'clock is when the temperature goes very low. Okay, so maybe as the evening went and as the night started, the temperature started going down. Okay, from 6 to maybe, let's take it was at 10 degrees Celsius. From 10 it went on to 9, 8, 7. So if this was at 10, the water here would also been at 10 degrees Celsius. Now when the temperature started falling down, okay, from 10 it went on to 9. Now what will happen? Till that time what would have happened? Now, so temperature decreases, so it will contract. So the water layer at the top, which is close to the atmosphere, the water was 10, now it's coming down to 9 degrees Celsius. That means it would have contracted from the previous volume. Now when it contracts, its density increases. Okay, contracts means density increases. So when its density increases, it cannot stay at the top. So naturally it will sink down, means it will come down. And the next layer of water, which is still at 10 degrees Celsius, that will go up. Okay, and then that layer comes in contact with this 9 degrees Celsius, and that becomes 9 degrees Celsius. Then, so like this, every layer will turn to 9 degrees Celsius. So like this it keeps going on from 9 to 8, then 8 to 7, 7, 6, 5. Till 4 the same thing will continue. As the temperature goes down, it will contract. Okay, so till 4 degrees Celsius, contraction will take place. So density will increase, and so the water will go down, and the next layer will come up. Like this goes down till the entire layer becomes 4 degrees Celsius from top to bottom. Now the outside temperature is also 4, and inside also all the layers have, the water inside, all the layers are at 4 degrees Celsius. Now below 4. Now what happens below 4? Now if till 4 the same thing would have happened. We call it convection current, if you remember. So the colder layer will come down, hotter layer will go up, that gets cold and come down, like this current will be formed. Now when it comes below 4 degrees Celsius, now something else will happen because of anomalous expansion of water. You know that very well. Instead of contracting, water will start expanding. When water expands, its density decreases. Okay, molecules will go far apart, so its density will decrease. Okay, so what will happen? Now this water layer which was at 4, now it turned to 3. But because its density has decreased, now when compared to the layers below, it will be at a higher density. Now you know that a higher density will always float. Sorry, density decreases means its density goes down, means it's of lower density. Only a high density thing will sink. If anything of low density is at the top, it will remain floating. Simple example, if you have a cork ball, if you have a plastic ball whose density is very less, how much ever you try to push it inside water, it's going to come up because its density is less than water, it will remain floating. Same way, this water layer at the top, when it goes below 4, its density is going to decrease. That means it will become lighter, less denser, and now no more it can go down. That means this layer will remain static here. This layer will remain static here. So you can take it as 4 degrees Celsius. So it cannot go below that. It will remain at that. So what happens? The layer below will remain at 4 degrees Celsius. So this layer, and so no more convection current is formed. Now this layer might go from 3 to 2, then 2 to 1, and to 0. Okay, like that it will go down, but no more convection current will be happening, because from 4 to 0 its density would have decreased, so it will remain at the top, only its temperature will keep going down. So the top layer will now reach 0. You know, once it reaches 0, it starts freezing. Now, so it will freeze and become ice. It will freeze and become ice. Now, the layers inside will be at 4 degrees Celsius. They are not going to go below 4 degrees Celsius. Now, ice, you know, it's an insulator. Ice is an insulator. So, it will not allow this heat inside. Now, when compared to the outside atmosphere, maybe 0 degree or minus 10 degrees Celsius, water inside is at a higher temperature. 4 degrees Celsius is higher than minus 10 degrees Celsius. So, what will happen? This ice will not prevent the heat from going out. As a result, the water inside will remain at 4 degrees Celsius itself. So, this is what happens. Maybe the layer that is close to might reach 0, but then as you go down, okay, maybe because this is ice, this layer might be so 1 degree, then 2 degree, then 3 degree, like that, but lowermost layer will be 4 degrees Celsius. So this is how aquatic animals are preserved, because the temperature inside will always remain at 4 degrees Celsius. It will not go below that. Now this is a very important question that keeps coming often. So it's good if you understand it better. The explanation actually starts, you can read the whole thing. For the answer, it will start from here. When temperature of water near the surface starts, when temperature of water at the surface falls till, okay, cut off below and write till 4 degrees Celsius, what will happen? Water will contract, density increases, and therefore it sinks to the bottom. This continues till the temperature of entire water reaches 4 degrees Celsius. That's your first point. Second point, now further cooling of top layers below 4 degrees Celsius results in expansion of water, and so its density decreases. As a result, water does not sink further, but it remains on the surface. Third point, when the temperature of atmosphere falls below 0 degrees Celsius, water on the surface loses further heat and gradually freezes into ice. But water below this ice layer remains at 4 degrees Celsius. That's your third point. Come to the fourth point, it's here. Since ice is a poor conductor of heat, ice prevents the flow of heat from water to the atmosphere. Thus, temperature of water is constant with ice at 0, while the temperature of water layers below gradually increases to 4 degrees Celsius. This diagram is also important. At the top, you will mark ice at 0, then 0, then you can just mark 1, 2, 3 like that, and the lowermost will be at 4 degrees Celsius. So, hope you have understood this. This is a very important question, okay, along with the diagram. All these 4 points that I told you need to write. Okay, this will be the answer for question 18C. You have reasoning questions in the next page. So 18th question C part. Fishes survive in ponds even when the atmospheric temperature is below 0 degrees Celsius. So that will be the answer for that question. Okay. Now there are other consequences also. One is in very cold countries, maybe we may not observe it in India, but in very cold countries, sometimes the water pipes, okay, the pipes carrying water, they might burst. Okay, that happens in very cold nights. Why does it happen? In winter nights, as the atmospheric temperature falls below 4 degrees Celsius, water in pipe starts expanding. Because of anomalous expansion, water starts expanding and it exerts large pressure on the pipe. Till 4 it was contracting, so there was no pressure. But after 4 it will exert pressure on the pipes because it starts expanding. Now because of that large pressure, the pipes might burst. Now the same phenomena might happen in plants also. You would have heard this, if it's very cold, if temperature goes to 0 or even -1 degree Celsius, crops will get damaged quite a lot. The farmers are very much affected because of that. Why does that happen? Same way, like what happens inside a pipe, water pipe, same thing happens in capillaries of plants which carries water. Okay, plants also die for the same reason. So their capillaries burst when water in them reaches below 4 degrees Celsius and expands. Okay, same thing will happen and the plant gets damaged. Now to protect this, the fields are filled with water. The field is filled with water. So usually they do that so that it will not go below. So this can be asked as a question. Give reason why a farmer fills a field with water in very cold nights. The answer will be this one. Children, next you can turn to page number 130, the next page. There are some reasoning questions given. We are going to try them. Okay. The first one, water pipes in colder countries often burst in winter. That I have already marked for you. In winter, water tank starts freezing from the surface and not from the bottom. Now, this will have the same answers of fishes survive, but you don't have to talk about the second part. Okay, so in the sense, the same explanation you will write, but you don't have to no, the same thing will come. Okay, so in the fishes survive thing, you will write a result also. As a result, fish and other aquatic creatures remain alive. But if the question is asked like this, you just explain this phenomena till this and stop it. For the next question, if it was like fishes survive in ponds even when the atmospheric temperature is below 0, for that also same explanation, but you will conclude it like this. Okay, so that's the only difference between these two questions. So you write it once, that's enough. Now coming to the D and E part. D part, a hollow glass sphere which floats with its entire volume submerged in water at 4 degrees Celsius sinks when water is heated above 4 degrees Celsius. And read it again. A sphere that was floating when the water was at 4 degrees Celsius started sinking when the water is heated above 4 degrees Celsius. Now, so this is D part. Now, okay, let's take a beaker containing water and this glass sphere is floating in it. Okay, it was floating in it originally and you are heating this water. Maybe initially it was you took this water from fridge, so it was at 1 degree Celsius or something, then you started heating it. So what will happen? So it is at 1 degree and you start heating it. So till 4 degree what will happen? Till 4 degrees Celsius, water, when you heat, generally it has to expand, but water will contract. So water contracts. So what happens to its density? Density will increase. When water contracts, its density will increase. So I can write density of water is greater than the density of glass sphere. Till 4 degrees Celsius, the density of water will be greater than density of the glass sphere. That is why it is floating. This concept you all know. Any light object, that is, any object whose density is less will float. And any object whose density is more than water, it will sink. Right? So, that is the reason why it floats. The second case, when you heat it above 4 degrees Celsius. Okay? What will happen above 4 degrees Celsius? Water will expand. It won't contract. It starts expanding. And so, its density will decrease. Now what will happen? The density of water will become less than density of glass sphere. Or you can say the density of glass sphere is more than density of water. That means the sphere's density is more. Now it will start sinking. Therefore it sinks. So this is how your explanation should go. You should write both these cases and explain. Come to the E part. A glass bottle completely filled with water and tightly closed at room temperature is likely to burst when kept in the freezer of a refrigerator. So some of you might have observed this. If you take a water bottle and completely fill it, means till the brim, you have not left even a small space. Okay, then you tightly close it and you put it in the freezer. You leave it for some days. Sometimes after some days you will see the bottle bursting inside. Sometimes even Coke bottles happen like that. Why does it happen? That's the question. Okay, so how does the explanation go in this? So in this, the water in the bottle, maybe you filled it from a pipe, tap water, which would have been say 25 degrees Celsius, and now you put it into a freezer, inside a freezer, and the temperature starts going down from 25, 24, 26, 23, 22, like that. It keeps going down. And what happens till 4 degrees Celsius? Okay, from say 25 degrees Celsius to 4 degrees Celsius. So in this, it is cooling. Okay, temperature is falling down, so it will contract. Yeah, so this, suppose you filled it from a tap, so water was at 25 degrees Celsius, and now you put it in a freezer, it starts cooling. In the previous case, it was heating. Okay, we talked about the water getting heated and its temperature increased. Now it's cooling. Water was at a high temperature, maybe 25 degrees Celsius, until 4 degrees Celsius. What will happen? Water will contract. Water contracts, and so what will happen? Density will increase. So volume, when it contracts, volume will decrease. So nothing will happen to the bottle. Now, between 4 and 0, below 4 until 0. Okay, because the fridge temperature will be at 0 or less than 0 degrees Celsius. So it has to reach till that temperature. So once the temperature goes below 4, water will start expanding, and so its volume will increase. Volume will increase. Now, in the bottle, because you had filled till the brim, there's no place for expansion. So, sometimes the volume will expand so much that it exerts a pressure on the bottle, and the bottle will sometimes burst. So, that is the answer for the E part question. Okay, remember there we are heating, water was at 0 and then you are increasing its temperature. Here water is at a high temperature and you are cooling by keeping it in freezer, and so this is happening. So for today's homework, you will be writing all these 5 reasoning questions in your notebook. B and C will have the same answer. So rest all, will have different answers. Please write them clearly as I have explained. We go to the B part now. That's it's a very simple concept, energy flow and its importance. You've studied a lot about it in biology and other subjects. Food chain, yeah. So it goes like this. Producers take energy from the sun and prepare food, and these are consumed by primary consumers, and they are consumed by secondary consumers, they are consumed by tertiary consumers, and then they are consumed by man, and then they get decomposed. So like this is called a food chain, a simple food chain that you've seen. Now we are going to see how some laws of physics can be applied to this food chain, or this food chain follows some principles according to physics. So we are going to try and understand that. Now have a look at this table. It has lots of numbers. Don't get frightened because of that. Okay, so I'll just explain it clearly to you. Okay, so this is energy flow in an ecosystem. It starts from here. Okay, the arrow mark is like this. So from sun, producers, then primary consumer, secondary consumer, tertiary consumer, and then it goes up. So they have taken one example. Now plants produced or used 20,000 calorie of energy from sun. Okay, 20,000 calorie of energy they took from the sun, and out of this 20,000 calorie, nearly 12,000 calorie was used in growth and respiration. Now you should remember that plants, all the energy that they take, it's not used to produce only fruits or vegetables. Like that is what is going to the next level, but it needs energy for doing the other things also. The plant has to grow, the plant has to develop. So some energy goes to all these things, and only a part of it goes to fruits and vegetables, that goes to the next level. So that is what they are saying. Now out of this 20,000 calories, nearly 21,000 calories that it took from the sun, nearly 12,000 calorie was used for its growth and energy for plants and for all these things it was used. So remaining 8,800 or nearly 9,000 calories only goes to the next level, or fruits or vegetables or whatever is being consumed, only this much calorie is being used by the next level. Okay, so this is called gross. Gross means without any reduction, the total energy that was produced. Net means after all the waste and other things, the amount of energy that goes to the next level is called net. Now, okay, we pluck the fruits. Now, we may not be able to consume all the fruits. Some might get wasted, some might get decayed, some might get spoiled. So, though nearly 9,000 calories was used in producing fruits, for example, you take a mango tree, okay? So, 9,000 calories went on to producing the fruit. But out of that 9,000, definitely some are going to get wasted. So, they are saying nearly 5,500 calories will go in decay, okay? And so, the left out energy, that is some 3,400 calories only goes to the next level. So I hope you understood this. So out of this total energy of 21,000 calories that the producer produced, all doesn't go to the next level. Some of it goes to its own growth and development. Some of it gets wasted, death and decay of the fruits and vegetables, and only the remaining goes to the next level. Now the same thing will continue at every level. So the energy keeps on decreasing, and finally very less energy only goes to the tertiary consumer. Okay, now how does this relate to physics? Now let's come to the application. Now see this. So the first conclusion that we are going to get from this is energy flow in ecosystem is linear. That is, it moves in a fixed direction. Okay, you know the difference between linear and cyclic? Cyclic means you have studied about carbon cycle, nitrogen cycle. Those all start and come back to the same place. Now this one, energy flow doesn't come back to the same place. Okay, it starts and it keeps going like this. This is called linear, a straight flow of energy. So that's the first conclusion. Energy flow is thus linear. It moves in a fixed direction. At the end, energy reaches to the degraded state. It does not return to the sun to make the process cyclic. So that's the first conclusion you're getting. Apart from this energy flow obeys two laws of thermodynamics. In physics, there are two laws. That's laws of thermodynamics. It's very important, and those laws are also obeyed by this energy flow in an ecosystem. Let's see how. The first law says, according to the first law of thermodynamics, also known as law of conservation of energy, this you have heard many times, energy can be transformed from one form to the other, but it can neither be created nor destroyed. So you see this happening in this energy flow, where energy is neither created, it just transformed from one form to another. Okay, that's how the first law is obeyed. The second law of thermodynamics is this. According to the second law of thermodynamics, when energy is put to work, a part of it is always converted to unuseful form as heat, mainly due to friction and radiation. So in a machine and all that, this is a common thing we say, always some energy is wasted. Simple example, a fan is rotating now. Fan has to give you breeze, but if you see, after some time, the motor of the fan would have got heated up. Why? Was it needed? No, but you can't avoid it. Why? Because of friction and other things. Same way, there will always be some form of unusual form. Means not all the energy will go from one level to another level. Some energy gets wasted or it becomes unuseful form, but total energy will remain the same. See how this is the law of thermodynamics. See how it is applied in this thing. Energy used in respiration and in decay or death appears as unuseful heat energy because this energy does not reach to the consumer of next stage. Okay, so this is how second law of thermodynamics is followed in energy flow in an ecosystem. So the question that comes is, you don't worry about this table, this numbers and all that. Usually what they ask is, what are the two laws of thermodynamics that is applied in energy flow in an ecosystem? Explain it. So state the law and explain how it applies to energy flow in an ecosystem. That's all for today. Thank you, children.